Hey guys, welcome back to the channel. I have another PCM test and possibly repair. This is a 2004 F-150, 4.6 liters coming from Texas. Raymond Canseco, this is your computer. His concerns are P0443, and he says sometimes when the computer or the temperature outside is over 100 degrees, the car gets hard to start. I'm not sure if I will be able to reproduce something like that, but I will definitely check the signals, cam and crank and so to see if we have any issues with the analog to digital converter, which is very common on these vehicles, but not that. So usually when you have a temperature, they're related like in something specific of the outside. I will look into something else that is definitely not related to the computer itself, because unless it's, when the engine gets really warm and something like that. But let's read the notes together, right? So as I normally do, I get a full folder for the customer, pictures of the computer. As you see, I have already opened it because I want to correct the problem with the first solenoid. This is his computer, and the tier tag is KEA1. Again, this is a 2004 computer, and you can see the picture if this gets to focus into here. This is the cover that goes right here on the back of these computers, and I kept it in there so we can see as well that I got the scanner connected and already connected to the computer. But let's take a look at the folder first. All right, I got all the wire diagrams in case we need it, but I also have put together something for you that we can quickly see that. All right, so this is just for all of you and him connected before even opening it in here, and then at the right side where I can check the B number CA06387, and then same thing on the scanner with the picture right there. This is the note. I have a code for P0443, and sometimes hard to start when weather is over 100 degrees, no fuel, no spark. Yeah, that is, honestly, I have seen this more and more often being the instrument cluster, because in this vehicle, the PATS, the passive anti-theft system, is built into the instrument cluster when it's something like that related to temperature. And why am I saying that? Well, think about it. Where is the worst temperature that happens? Inside the cabin of the car, right? Because the engine, even though it gets warm, you have all that air that can go down from underneath of the car, right? Inside the vehicle, inside the cabin, not so much. And I have seen that being the case most of the times when it's related to outside temperature. All right, it says fuel pump was replaced in crankshaft sensor from 4 only like 3 or 4 times. I don't know, from 4 only like 3 or 4 times in 6 months of use. It is done it. Not sure why he refers to that. A little far hard to understand. In 6 months of use, it is done. It is done it. Check codes and bidirectional tests with force scan and fuel pump spark and the purge valve solenoid. Everything works fine. Notice high spike on purge valve solenoid when applied bidirectional. Yeah, that's normal because it's a solenoid. When bidirectional control test on the ECU or PCM, just one time cannot duplicate the problem. Fuel gauge sometimes take few seconds to respond. Again, you see what I mean? So we might have a problem with your instrument cluster rather than the computer. Sometimes take a few seconds to respond, and sometimes when no start, done it 3 or 4 times. Okay, let me reread that. Fuel gauge sometimes takes few seconds to respond, and sometimes when no start, and sometimes what? And sometimes when no start. Fuel gauge sometimes takes few seconds to respond at, maybe an. I don't know what that ad means. I'm going to get you guys a little closer. I'm reading right here. So it's a little hard to understand the wording. Fuel gauge sometimes take few seconds to respond at same time when no start. Done it 3 or 4 times. Yeah, you see, so now, like, it was probably my eyes didn't read it right. So it's at the same time. So it's because he forgot to put the D in there at the same time, but that's fine. Otherwise, is reading okay. Code P0443 is permanent code. Fall in system. Purge control valve circuit. Purge valve was replaced with motorcraft part. Please fix it. Thank you. Hope it's not very expensive. that's a that's very good. We already discussed because I thought when he told me that this is a 4 F-150 Heritage, I thought it was a Lightning because usually Heritage is Lightning, but no, this is just a Heritage for 4.6. These are not an expensive repair. And yeah, he said on the top, I sent an email on you on September 10, which I have in here. I can show you, but I was about to leave to Alaska. And so he hold for me to work, and he's like, Mike, I watch your videos, and I know that you're the person that I want my computer to get fixed with. I trust you already, and I've been following your channel for a long time. So thank you, Raymond. And it's here. All right, so let me see what else we have here. Well, this is just the pinouts for the computer that I was using myself for the test. I want to show you this one. So the purge valve is on pin 56. This is a computer with a 104 pin connector. On the right side of here, we got also the pinout. So the resistance of that purge solenoid is very important to be in between 30 to 38 ohms. If you have a valve that is not between those specs, it will set up a fault and the computer will not like it, and it will probably work, but it will not. You cannot get rid of the fault code because it's the incorrect resistance. You can also do a test. So sorry, guys. I'm a little tired. It is 6:30 p.m. by the way, and I start working. Even though my business hours shows at 9, I'm usually already working at 7:30 a.m. So what I was going to say, you can command the purge valve and put an amp clamp, or use your multimeter through the multimeter in amp mode. When you turn the purge solenoid on and off, or fully grounded, if you can do that too, because you have a test to do on and off, and that will do it. The draw that valve should have is in between 0.3 and 0.5 amps, no more than that. Otherwise, you have a problem in the wiring or something. If you do the test like what I was just describing in here, and you have the correct resistance and the correct amperage, still that fault code cannot be raised. The problem is internally in the computer. More than enough testing, and you can send the computer to me. All right, so let's see if we can reproduce the problem here, which I think we can. I have done this test. I have a test lighting here which matching that resistance. I put a resistor in place, and the amperage matches exactly. So I don't need to buy a valve because this is only for me for do testing. So I can put the 30 to 38 ohms resistance in place, consider what the resistance of that light is, and then use it as a test to reproduce or not the concern. So right here, you can see a light, and I can move that camera a little bit. Yeah, like that you can get a better idea of what I'm talking about. So I'm connected to positive of ignition, and then the other side is connected to pin 56, right? That we have also already. So in that diagram, that is the pin out, or the correct pin for the purge valve in scanners, and you're going to see that here. So I'm going to put now the full probe just to run the car when I need it to, because we're also going to try to reproduce the cranking problem he has, or if we can. And also I have the scanner connected. So actually the computer is now off. So let me turn the computer on. All right, so the computer is on and the full probe is off. So we need to turn that ignition on. Right now the ignition is fully on. But I want you to see the fault codes in there. Was I running before the test to record a video? Let me just see. Okay, right here we got the second line. I'm actually, let me put it as the first line that you're going to see right now on the scanner. P0443 system purge valve fault. That should not be here. Why? Because I have a correct load. Let's call the valve, or in this case my test light. I have the correct load, and I know my wire integrity is perfect. It should not be there. But let's redo the test. So I'm going to clear fault codes. all right, because we're erased. Let's see what we have in memory. Should be only a fuel pump and maybe P1000. Correct. That's exactly all we have. See if we have any pending codes. It should be none. Perfect. And now let's do the key on, engine off, the first test, right? That's the key, sorry, KOEO means, and the key, sorry, trying to, too many different things on my brain, right? KOER means key on, engine running. So the first one on the left, we're going to do a self-test. This should actuate the test light. Let's see if that happens. And it does. All right, so it is definitely not fully dead, right? But we have the fault code. So let's see right there. I'm going to put it right at the top. We get the P0443. That fault code should not be there. So we can definitely immediately set that the problem is internally in the computer, because I have done this test in multiple computers, and I can put, links to the videos of those that I have done in the past, and you'll see when this one is fixed using the same test light connected to the same port, and it's gone. But we'll see that. All right, so the next thing we can do is we're going to go into functional tests, and in here you got to go over to the EVAP management valve on and off. So that's this in here. And in this says we can command the valve on and off. Let's also see if we have, let me do a custom selection, because sometimes you can look at voltages at the same time. It's been a while since I don't do this one, so let me deselect all. And let's see if we have anything about this. And this is where I always complain, the manufacturers, they give you a whole list of anything that you don't really need for these tests. Why am I looking at, par neutral, or throttle position voltage, or maybe fuel trims? I can probably understand on that. DPF voltage, I have the DPF voltage, but I cannot see anything on the EVAP system in here. Do you see anything for the EVAP in here? So we got the EVAP solenoid purge valve, and we got the EVAP bend valve. Nothing in here as far as voltage or anything. And I know, in this case, these computers don't have that much control on those, so that's probably why you cannot see that, because it's not a sensor, it's an output. But then don't put all this junk in here that is not really important for me or for anybody, realistically. All right, so we're going to just go, I'm going to select one, because realistically, let's just put a list view, and that I can click on the on and off. All right, so when I click on, that light should light up. Now you can see that I am indeed on the correct valve, and when I turn them off, it goes off. So the computer is able to command it, and the valve is moving, but something internally in the computer is either now wrong, it cannot read the correct resistance, and it's setting that fault all the time. So, and most of the times when I have seen this, is the analog to digital converter that it takes in charge of those signals to go back, because this is an analog signal, and it has to be transferred over, even though it's not like an on and off or pulse width modulated signal, which in some of the vehicles is. But yeah, we cannot see that. So let me try to perform the repairs and see if we can correct this. But before we do that, let's go over to, I actually have the RPM, so let me go over to the Full Pro, because the computer is now, yeah, it's getting warm. I would say probably around 90 degrees. And I have been using these Clean Tools. This is actually really handy. It's the Clean Tools IR07. Yeah, IR07. This is a very handy tool. It has even a probe that you can poke into or put them into water or fluid, so you can just leave it hanging in there. This is for HVAC, but it's actually really good. Let me just see that. No, that was me holding it. But it has also an infrared sensor. You can use it as a pointer, but that's a thermometer, right? So let's see. Okay, we are in 90 degrees. I have very good thermometer calculation in my fingers, huh? And I was going to show for some other customers, there are sometimes like, what's the normal temperature? Look at this component right here. 270 degrees Fahrenheit. Why is it so hot? That's got to be bad. No, it's not bad. This is the main diode on this computer. So that is now taking place of all the loads. I mean, even though you don't see in here, I have, the simulator with loads that are being turned on and off. And obviously that's going to, all the amperage is going directly to that because that is the main protection diode. So yeah, all the amperage is going in there. That should be very warm and is warming up the rest of the computer because this has a big heat sink. All this metal here is touching the computer with a thermal paste that will transfer the temperature so none of those components get damaged. But yeah, there are going to be some components like the microprocessor or so. There are a 90, 93, and this is without an engine running. And they're all, or I mean, some components are going to be in a higher temperature. Like look at this one, 270 degrees, 260 degrees, sorry. So yeah, nothing abnormal with that. And I see that all the time. But yeah, let's try to run the computer right now. I'm supplying the same signal that I always do for low RPMs, which is, again, a crank no start will happen in low RPMs. So it's signal 51, and I'm going to put 400 RPMs to see if it runs. And it's like, I mean, instantly. So you can see the spark right there on the full probe. And I can move you over, guys, to this view where you will be able to see this load that I have there. You see, those are the two boxes that you can see the spark plugs firing because I haven't not done the parameter reset, and I don't need to because if I have a spark, I will have injection. But this is definitely not looking, like I said, onto the computer. So I'm going to turn it back off as far as RPM. Turn the ignition on again and do it one more time. And I want you to see when I just put the RPMs, it's instantly running the coils. And he was saying no spark, no injectors, no fuel. That sounds to me, Raymond, like the problem in the instrument cluster. So yeah, I will now move into the P0443 and I'll be right back, guys. All right, guys, I finished the repairs on Raymond's computer. Let's do the test, right? So let me get actually in the screen here because I moved the scanner away, but I don't need it because I have TeamViewer. All right, so the computer is on. Let me actually move the view here so you can get to see again the same thing. Let's clear the codes first, just in case anything isn't there, which I really doubt it, but let's check the same way we did before. Like that is going to be the same exactly thing. So no codes in memory code, pending code should be nothing. Let's do key on, engine off, cell test, and let's see the activation of that valve through, my test light. Consider, well, actually it looks a lot brighter, right? So that is definitely a lot better. All right, perfect. I can immediately see there is done properly, and obviously it's brand new components in the computer. But yeah, we got P0453 EVAP pressure sensor high, which we're not. P0446 bend control solenoid is not connected. But the 443, I'm going to scroll slowly down so we can see all that fault code. If the 443 would be existed, would be right next to those. So I'm already know that it's not there. But I'm just going to scroll down all the way to the bottom to just make sure that nothing else is in here related to that P0443. Well, there's actually P0446, 406 in here. So, yep, that fault code is completely gone. So your computer is fully repaired. I'm going to do the test as we did before, the on and off test. So you can get to see that I'm exactly in the same exact pin. So I'm just going to do the on and off, so it makes no difference. But yeah, we can definitely now see, now that I'm looking at that screen, I'm looking at my iPad. You wonder probably why am I looking down? I'm trying to see what you're seeing to make sure that everything is being captured properly. But I can definitely see a brighter light than before, which means that, yeah, it was actuating or activating the valve, but not fully. So that's why the fault was going, or setting. Right now, with the correct load, correct resistance, we can see that fault code is completely gone. I'm also going to run the computer. Once again, Raymond, I think your problem about the running should be probably in the instrument cluster than anything else, especially because majority of the time that I have seen these computers having any issue is in low idle. And yours, the way it's picking up the RPMs is so quickly that I doubt it is here. So I'm going to do a different test this time. So let's do the same test that we did before, which was just supplying the RPM signals with the computer power on. So I'm going to power the completely computer off, but I'm going to leave that signal in the pull probe being injected into the computer, and I'm going to turn the computer on just to see if by any chance we don't get a spark immediately. And it's not. So this definitely moves me away from computer being the issue with at least crankshaft or camshaft position sensor signals, or anything else that is related to go through the analog to digital converter in your computer, Raymond. The problem again that you have in there is probably the instrument cluster or pads. It could be the antenna too, because it's not abnormal that when it gets so hot in the cabin, it damages those components. Mostly I will go into the cluster because it's right at the dashboard, right? So it's the one that receives all the sunlight and everything for many, many years, right? 2004, 21 years, and I'm not sure. Well, actually, it says that you have 100 and let me see how many miles. 111,000 miles. So it's not a huge amount for a 21-year-old vehicle, but it's still a good amount of mileage. So that means the car is being obviously used and is exposed to all those high temperatures all the time. All right, guys, thank you so much for visiting the channel. If you're here, please don't forget to subscribe. That really helped my small business so much, and I really appreciate if you do so, because every time you subscribe, YouTube promotes my videos more and more, and that's how you find me. It's also for free, and that really helped my small business. So thank you so much if you do so. If you're here and you need a computer to be sent for repairs, automotive or marine or instrument cluster, I'm going to put in the title of this video my website so you can copy and paste it. And then in my website, if you get in the homepage, as soon as you open it up, you will see my address on the center bottom. Right next to that, you have a white box that says here, click here to fill this form. You please download that form, fill it, sign it, and add it in the box. And also use the other box that says, click here to email us. Like that, you can send me an email. We can start having a conversation. Like that, I can understand better your concerns, the problems on the computer, and so on. All right, guys, thank you so much. See you next time. Bye-bye.